Hello everyone. Hope everyone is still okay despite of the busy schedule of the last days of the school year 2021 to 2022. So I resorted to making this video lesson because we were not able to meet face to face in the past few days. Although I tried to make some arrangements, but then it kind of didn't work because it actually clashed with other subjects. And so I resorted to this one. We cannot have the face to face anymore next week because advisors should be busy next week preparing for the final grade sheets in order to determine the honor students per section. So I hope you would understand why I am doing this flexible, what do you call this, medium in order for us to have lessons for the fourth quarter. Now, this would be the last part of the fourth quarter for me. This is the pH. The first part would be about the introduction about the Bronsted-Lowry acid theory, and the second one will be about this one, pH, a measure of acidity. So, in this lesson, you'll be using your um, scientific calculator in order for you to calculate for the pH and POH of an example compound. So let's have a sort of review from the previous PowerPoint video that you have watched. So let's have question number 1. According to the pH range, let me point it out. According to the pH range, which substance is more acidic than lemon juice? So it ranges from 0 to 14. So we have hydrochloric acid, lemon juice, cabbage, milk, water, milk of magnesia, or lye. So you have to choose between letter A, cabbage, B, hydrochloric acid, C, milk of magnesia, and letter D, none of the above. So let's reveal now the answer. The answer is letter B, hydrochloric acid. So hope you are able to get it correctly. Next question. What is the H plus if the pH is 4.0? So if your answer is 1.0 times 10 raised to negative 4, your answer is correct. Let's have question number 3. What is the pH of a solution that has a H plus of 2.5 times 10 raised to negative 5? A, 5, B, 4.60, C, 2.5, D, 7.0. So what do you think is the answer? So if your answer is letter B, you are correct. Let's come now to number 4. What is the POH of a solution where the OH is 7.3 times 10 raised to negative 2 molar? A, negative 1.14, B, 7.3, C, 1.14, D, negative 2.0. If your answer is letter C, you are correct. Let's come now to number 5. Pollution causes the pH of rainwater to below 6. What is such type of rain called? A, acid rain, B, low pH rain, C, non-point source pollution, or letter D, polluted rain. What do you think is the answer? So the correct answer is acid rain. So no need for this one. Okay, so let's have this one. pH and POH. In 1909, Søren Sørensen, a Danish chemist, proposed a more practical measure called pH, since the concentrations of H plus and OH negative in aqueous solutions are extremely very small and thus inconvenient to work with. What you can see here in the slide, yung picture of a man is actually, he is actually Søren Sørensen. So the pH of a solution, which stands for power of hydrogen, is defined as the negative logarithm of the hydrogen ion concentration, which is in molar or mole per liter, and as such, the measure of acidity and basicity of a solution. In terms of hydronium ion concentration, the equation to determine the pH of an aqueous solution is pH is equal to negative log H3O plus, or pH is equal to negative log H plus. So we will have this formula a little later, and then we'll try to solve some problems here. Okay, so continuing with this one, the pH of a solution, which is stand for power hydrogen, is defined as, okay, kanina na pala, nandun na yan kanina sa previous, ito yung kasunod niya. The equation above is simply designed to give us convenient numbers to work with. Okay, the negative logarithms gives numbers for pH which otherwise would be negative due to the value of H+. So, this is explained by the computation later. Okay, so because pH is simply a way to express hydrogen ion concentration, acidic and basic solutions at 25 degrees Celsius can be distinguished by their pH values as follows. When we have an acidic solution, you can see here, the pH here is less than 7. And then the H plus concentration is more than 1.0 times 10 raised to negative 7 molar. But when we have a basic solution, the H plus concentration is less than 1.0 times 10 raised to negative 7 molar, and the pH becomes more than 7. And then for neutral solutions, the H plus concentration is equal to 1.0 times 10 raised to negative 7 molar, and the pH is equal to 7. Now, observe that pH increases as H plus decreases. Let's see this one. So, for acidic solutions, we have more than 1.0 times 10 raised to negative 7 molar, pero yung pH niya is less than 7. But then on the other hand, basic solutions, this is less than 1.0 times 10 raised to negative 7 molar concentration of H plus, but the pH is higher because as the pH daw increases, the H plus values decreases. Kaya ito, mataas na ito. Pag meron kang pH na 8, mas mabababa pa yung value ng H plus concentration. Okay, so moving on. So on the other hand, when H plus ion concentration is being asked and the pH value of a solution is given, you need to get the antilog which is shown below. Ito, H30 plus is equal to 10 negative pH, or H plus is equal to 10 negative pH. A POH scale is analogous to pH scale. It is used to measure the hydroxide ion concentration. Furthermore, to express the alkalinity of solution, thus it is expressed as POH is equal to negative log OH. When POH value is given and the OH concentration is asked, you can take the antilog. It is shown as OH negative is equal to 10 negative POH. From the definitions of pH and POH, we obtain pH plus POH is equal to 14. Constant yan na 14 palagi kasi when you add the pH and the POH, that would always be equal to 14. Here is now the example. The concentration of H plus ions in a bottle of table wine was 5.2 times 10 raised to negative 5 molar right after the cork was removed. Only half of the wine was consumed. The other half, after it had been standing open for the air for a month, was found to have a hydrogen ion concentration equal to 2.0 times 10 raised to negative 4 molar. Calculate the pH of the wine on these two occasions. The strategy. We are given H plus ion concentration and asked to calculate the pH of the solution. What is the definition of pH? So based on the equation, pH is equal to negative log H plus. When the bottle was first opened, eto yon. H plus is equal to, nandito yan, 5.2. Ayan, 5.2 times 10 raised to negative 5 molar. And then we will use now the formula pH is equal to negative log H plus. So, negative log is equal to, eto, we'll use this, 5.2 times 10 raised to negative 5. Now, using your calculator, let us try to calculate this one. Now, using your calculator, scientific calculator, you may now input on your calculator the sign negative, and then you press the sign log, and then you input now the 5.2 times 10 exponent raised to negative 5, then you will arrive at the answer 4.28. But then on the slide, you can see that it's 4.3. It's already rounded off. So I hope you can see here in my calculator how I have calculated the pH here. Sana nakikita. Ayan. Ayan. Okay, that's the log. Negative log 5.2 exponent raised to negative 5. The answer is 4.283999 something. That's why, as you can see here in the slide, it's already rounded off. So meaning to say, the pH of the table wine with the molar of 5.2 times 10 raised to negative 5 is 4.3. So you can see, since it's 4.3, that means it's already acidic because it's below 7. Okay, let's move further. So on the second occasion, we will be also calculating the pH noong nabuksan na yung wine and then umalingasaw na siya. So let's try now to calculate its pH using the equation pH is equal to negative log. Then we will be using the 2.0 times 10 raised to negative 4. So let us try to calculate using our scientific calculator. So I will now try to input the negative log and then 2.0 exponent raised to negative 4. Okay, so the answer here in my calculator, I hope everyone will be able to see it. Ayan, negative log 2.0 exponent raised to negative 4. The answer is 3.69897000. Okay, 3.69. So this is now rounded off into 3.7 in our slide. So mean to say, mas naging acidic pa siya kasi 3.7 if I'm not mistaken, mas matbababa siya compared doon sa una nung bagong bukas pa lang yung wine. And that's how you compute for the pH of a certain compound given its H plus concentration. Now let's move on to example number 2. For example number 2, we have the problem: the pH of rainwater collected in a certain region of the northeastern part of the Philippines on a particular day was 6.45. Calculate the H plus ion concentration of the rainwater. So in this problem, the pH was already given and the pH is 6.45. Now in this problem, you are to calculate for the concentration of the H plus in the rainwater. And so the strategy to be followed is here. Here we are given the pH of a solution and asked to calculate the H plus concentration. Because pH is defined as pH is equal to negative log H plus, we can solve for H plus by taking the antilog of the pH. That is, H plus is equal to 10 negative pH. Now solution, pH is equal to negative log of H plus. Therefore, log H plus is equal to negative 6.45. Saan galing yung negative 6.45? Galing po iyon doon sa pH ng rainwater na collected doon sa northeastern part of the Philippines. Now, if you want to get the hydrogen ion concentration, then you need to get the antilog of the pH, and that is here. H plus is equal to 10 negative pH. That makes our 6.45 here becomes negative 6.45. Now to calculate the H plus concentration, we need to take the antilog of negative 6.45. So H plus is equal to 10 raised to negative 6.45. So let's try to use our calculator in order for us to get the antilog of the pH. Now we are going to input here the shift first in your scientific calculator and then press log. And then once you are done inputting the shift log in your scientific calculator, the next one is to input the value of negative 6.45. So I'm now putting in negative 6.45. And so the answer is 3.55 times 10 raised to negative 7 molar. Ganito yung lumabas sa aking calculator. Hindi pa siya naka-scientific notation. Pero if you are going to convert this into scientific notation, the same. 1, 2, 3, 4, 5, 6, 7. 3.5 times 10 raised to negative 7. So that's how you calculate for the concentration of the H plus ion in the rainwater. This is for example number 2. Now moving on, let's have example number 3. In a sodium hydroxide solution, Let me point out the problem. In a sodium hydroxide solution, OH negative is 3.5 times 10 raised to negative 6 molar. Calculate the pH of the solution. Now take note that you are asked to calculate for the pH here. You are not, hindi POH yung tinatanong, pH. So let's try to see what the strategy is. Solving this problem takes two steps, dalawang steps. First, we need to calculate the POH using POH is equal to negative log OH negative. That's the first step. And then the second step is, next, we use the equation pH plus POH is equal to 14 in order for us to get the pH of the sodium hydroxide solution. Okay, so let's come now to the solution. We use POH is equal to negative log OH equals negative log 3.5 times 10 raised to negative 6. Saan to galing? Diyan sa given sa problem. 3.5 times 10 raised to negative 6. The answer is 5.46. Now, using our scientific calculator to check if we have correct answer, so let's check. So I'm going to input here negative log, okay, excuse me, negative log 3.5 times 10 raised to negative 6. So the answer here is 5.45. Since renowned off na siya, the answer is 5.46. So we now have the POH. It's not yet the pH of the solution. It's now the POH. Now we use the equation pH plus POH is equal to 14. So pH is equal to 14 minus POH. So saan galing yung POH? Ayan, 5.46. So 14 minus 5.46, the answer is 8.54. Now that is now the pH of the solution, 8.54. Now check. The answer shows that the solution is basic because the pH is more than 7, which is consistent with the sodium hydroxide solution. You know, sodium hydroxide is a basic compound, and that makes the solution also basic. And that shows also in our calculation that it's 8.54. That's more than 7. That makes the solution also basic. So that's how you calculate for the pH if the given is the POH of the solution. Okay, so eto. So this will serve as your performance task in this activity. So it's called Activity 1. The title is What's My pH? So you are going to write this on a piece of paper, and then afterwards you are going to answer. Then you have to picture your answer, then send it to me. Amo po, i-send nyo sa akin sa account ko, wag po doon sa GC. Again, this will serve as your performance task in this activity for the fourth quarter. You are going to write it on a piece of paper, and then you are going to take a picture of it, and then you are going to send it to me for checking. So let's try to see. Number 1, the title is Activity 1, What's My pH? Direction, analyze each statement and answer it correctly. So we have number 1, pH is equal to the negative log of the blank ion concentration of a solution. Number 2, a student mixes strawberry powder and water. A pH meter is used to measure its pH, which is 5.4. What kind of solution is formed? Number 3, what ions are mostly present in the strawberry mixture's artificial color with a pH of 5.4? And then number 4, a student adds an Alka-Seltzer to the strawberry mixture and stirs. The pH meter now reads 8.3. What was released by the Alka-Seltzer tablet to cause this change? And last, number 5, baking soda is a weak base. Hydrochloric acid is a strong acid. What would happen if these two were mixed? So you have to write it down, take a screenshot of the activity, and then you write it down on your notebooks or on a piece of paper, then take a picture of your activity, then send it to me for checking as your performance task about pH and POH. Okay, this is the second one. Activity 2, calculate my pH or POH. So again, you are going to write this down on a piece of paper, calculate, then send the picture of your answer to me. Sa account ko mismo, wag sa GC. So direction, calculate the pH of the following aqueous solution. Number 1, determine the pH of a 0.0235 molar hydrochloric solution. Number 2, what is the pOH of a 2.5 times 10 raised to negative 6 molar solution of sodium hydroxide? Number 3, what is the pH of a 6.50 times 10 raised to negative 3 molar potassium hydroxide solution? And number 4, what is the hydrogen ion concentration of an aqueous hydrochloric solution that has a pH of 3? Is this solution acidic or basic? So you have to calculate this one, show your solution, then send it to me. This will serve as your performance task number 2 for this topic. Okay, so I will not ask you anymore to solve for this one because dalawa lang yung kailangan natin and that would be enough. But then if you would like to have to test your skill, then you might want to have a screenshot of this one for you to answer on your own. Now let's try to see how far have you absorbed the lesson in this video lesson. So let's try to have a wrap up. So fill in the blanks. So I'm going to read first and then you try to answer in your paper. And then I will reveal the answer later. So fill in the blanks. A blank is defined as the negative logarithm of the hydrogen ion concentration, which is expressed in blank units. On the other hand, blank is used to measure the hydroxide ion concentration. It can be used to express the blank of a solution. Because pH is simply a way to express hydrogen ion concentration, acidic and basic solutions at 25 degrees Celsius can be distinguished by their pH values as follows. Blank solutions is equal to pH less than 7. Blank solutions is equal to pH more than 7. Blank solutions is equal to pH equals to 7. Ready for the answer? So let's try to have now the answer. So number 1, a pH is defined as the negative logarithm of the hydrogen ion concentration, which is expressed in molar or mole per liter units. On the other hand, POH is used to measure the hydroxide ion concentration. It can be used to express the basicity or alkalinity of a solution. Because pH is simply a way to express hydrogen ion concentration, acidic and basic solutions at 25 degrees Celsius can be distinguished by their pH values as follows. Okay, number 5, the answer is acidic solutions equals to pH less than 7. Number 6, basic solutions or alkaline solutions is equal to pH more than 7. And neutral solutions, number 7, is equal to pH, which is equal to 7.0. So I know you got it correctly. That's why you deserve this one. Thank you so much to everyone. I hope you have learned a lot from our discussion today. So our face-to-face classes may not have come into fruition. I was only able to meet the STEM students ba yun? Yung kay Ma'am Marian, only the set B lang ata yung na-meet ko, while the ABM, I was able to meet the ABM set A and B, but unfortunately, yung isang section kay Sir Nichols, I wasn't able to meet them face-to-face, but then I hope this would also help you understand the nature of the acidity and basicity of solution. So with this, I thank you all for listening to our lesson, and I hope you will learn from this, because on Saturday we will be having our evaluation on this topic. Yung first part which is about the Bronsted-Lowry acid theory, and this one which is about the pH as a measurement of acidity and basicity of a substance. Thank you so much, everyone. Good luck on your journey to grade 12.